reciprocal apparatus, but really not as functional as we have the wet specimen. Might try doing that one. You can see the same thing happening here as well. Okay? Flexion of the stifle, flexion of the hog. Okay? But along with those features, we also have some other ligaments in this one. Okay? So what structure is going to be this one? That's your superficial digital flexor. In this one, we still have some part of the gastrocnemius left. Okay? Then this is some leftover of the deep digital flexor muscles. Usually originate on the caudal surface of the tibia. Your lateral, medial, as well as caudal tibial muscles, they are going to be this. Okay. Okay. Then this is your peroneus tertius. This is fibula. Okay. Then we have part of the cranial tibial left here. Okay. So that is the peroneus tertius, cranial tibial. Proximal extensor retinaculum. Okay. Yeah, this one here. That's a proximal extensor retinaculum holding both of them in place. Then we have middle one running this way, and then we have distal one.
It's okay.
So how many extensor retinacula here? We have 1, 2, and 3.
Maximum
Because of the way the extensors of the digit are passing over the flexor surface of the hog, they need more than one. There could be just one here may have worked, but it would then probably cause more friction with the joint. And so we have one here, and one here. Okay. Tibial tuberosity with crest of the tibia, insertion of all the patellar ligaments, okay. Medial patellar ligament, middle patellar ligament, and the lateral patellar ligament. Okay. Extensor fossa, origin of the long digital extensor as well as peroneus tertius. And remember, this is fibula, nothing else but the bone fibula. Okay. Okay, let's turn it to the medial side. Medial side here. So that's the medial side here. That is the common tendon of the DDF formed by lateral digital flexor and caudal tibial muscle. Remember what we saw on the specimen. The medial digital flexor does not join the tendon above the hog. It joins that tendon below the hog, and this is the tendon which we were talking about. I think somehow it has came off its groove where it was running through. It probably has to go from this passage here. The probe is now. Okay. It has to come down here and then join the deep digital flexor. Okay. Okay. Now what else we see here? The most important structure is the this one here. That is the accessory or check ligament of the DDF. Fortunately, this horse they prepared had the ligament, or it still has a ligament. Okay, so we have the check ligament or accessory ligament of the deep digital flexor. Now, how can we differentiate that from the medial digital flexor? You know, this is just round cord-like structure, while this one is more flat. It is extending from the caudal part of the joint capsule. What joint capsule is that? That is joint capsule of the hog. In the forelimb, that ligament is extension of the carpus joint capsule, which is palmar-carpal ligament. In the hind limb, that is extension of the hog joint capsule, but we don't really call it dorsal ligament also. Okay, so that is simply your extension of the joint capsule going to the deep digital flexor. Okay, what structure is this? Interosseous muscle splitting into two divisions. First of all, getting attached to the proximal sesamoid bones, and after that, continuing further in the dorsal aspect as the lateral and medial extensor slips of the interosseous muscle, joining the long digital extensor in the hind limb and common digital extensor in the forearm. Okay, so what structures are those? This is your extensor slip of the interosseous muscle, extensor slip of the interosseous muscle on the other side. Well, this is your long digital extensor tendon. The long digital extensor tendon, as it runs further down, it also receives the lateral digital extensor tendon. That's the lateral digital extensor. It runs through this groove or over the lateral malleolus, and then it continues further to join the long digital extensor. What we do sometimes, you find out that muscle in that groove, you expose the tendon and you transect the tendon. To get rid of like string hold, like jerky flexions of the hind limb, it is observed that cutting the lateral digital extensor would solve the problem. And as we don't need the lateral digital extensor much, because there is no lateral digit. So we can cut this tendon without having any adverse effect on the function of the distal joint. Okay. How do you identify the Cuneian tendon on this fixation?
Right there.
Okay.
Yeah.
The medial division, large trochlea or large ridge of the trochlea, medial side, that is medial division of the cranial tibial, that is the Cuneian tendon. Okay. Can we cut the Cuneian tendon?
No.
Okay. Can we cut that one? Or in certain situation, can we cut the tendon? Yes. Because the cranial tibial, because of the reciprocal apparatus, the cranial tibial has almost become non-functional. Okay, and that's why we can afford to cut the tendon of the insertion of the cranial tibial. Okay, now after you cut the Cuneian tendon, there is still one more ligament which is attached to the proximal end of the metatarsal bone. So how many divisions we have for the cranial tibial? We have two divisions: the dorsal division, which is attached to the metatarsal bone, and the medial division, which is attached to the tarsal bones and metatarsal bone. So we can afford to cut this one while the other one is still present.
Is it a part of the stay apparatus?
Not really.
No.
So the reciprocal apparatus is part of the stay apparatus, and so that's why the cranial tibial becomes almost non-significant. There is other thing which is observed, like when you have section of the peroneus tertius, the cranial tibial now try to compensate that flexion of the hock, but again that muscle alone is not capable of flexing the hock of the horse. So what you usually get, we get jerky flexions of the hock in that situation. Extension is not affected, animal can still bear weight, but when animal takes a step forward, it's going to be like flexions would be in that jerky manner or spastic manner also. Okay, now if you see a groove running right here on the cannon bone, which is on the medial side, that actually for the passage of the vein, and the groove on the lateral side, which is deep, okay, that is the blood vessel there, that is an artery. What artery would be that?
The main.
Dorsal metatarsal artery 3, okay, which will then go to the plantar surface. Okay. Splint bone, cannon bone, deep digital flexor, accessory ligament of the deep digital flexor, superficial digital flexor, its first insertion on the calcanean bone, and then further continuing its insertion on the middle phalanx. But where on the middle phalanx? Right at the proximal end of the middle phalanx. And so some fibers are also attaching to the distal end of the P1, making the Paston joint immovable. Okay.
Pile of legs. It's a pile
Look at
of
this
legs.
one, which would give you a little bit better idea of that. Okay. That is the SDF tendon here. These are the digital annular ligaments. I'm just spreading them out so that we can see the SDF properly. Okay. So what we have, superficial digital flexor splitting into two divisions, inserting on the proximal end of the middle phalanx. While your deep digital flexor then continue further down to insert on the distal phalanx. So what do you call that structure? Manica flexura. Okay. So that manica flexura, as we only have one single digit, we only have one. In the dog we have 4 functional digits, so we have 4 of them. In the ruminants we have 2 functional digits, so we're going to have 2 of them. Okay, so that's the manica flexura, which is simply splitting of the superficial digital flexor to allow deep digital flexor to go further beyond. Okay, and so it inserts on the proximal end of the middle phalanx. Okay, what other structure attaches to the proximal end of the middle phalanx, but in the center, between the 2 divisions of the superficial digital flexor? The ligament which is present right here, the straight sesamoideal ligament. Okay. So what we see here, look at this preparation here, like in this region, as the DDF and SDF are running over or running on the coronal surface of the fetlock joint. See, the superficial digital flexor has formed a tendon sheath around the deep digital flexor. So this one is all the possible arrangements to reduce the friction between different structures and cause any inflammation because of their friction and damage. Okay, so that is the SDF, that is the DDF tendon. Then as we see here, as they pass over the caudal surface or plantar surface of the fetlock joint, now something needs to hold them in place. So what is going to hold them in place?
Angular
That ligament here that we have
tendon.
cut. That is your annular ligament. Okay. Now this one is your plantar annular ligament because it is on the hind leg. If this was on the forelimb, then it would be called palmar annular ligament. As we come further down, we still need something which would hold the tendons in place. So we have proximal digital annular ligament. All of that here, that is I'm pointing out or I'm pressing down now, all of that is your proximal digital annular ligament. And then we have distal digital annular ligament, which is located far down to the which will be securing the deep digital flexor tendon. Okay. Okay, now when we lift up this one, and we also have already cut the plantar annular ligament, what structure is that? Okay, proximal scutum. What is the other name, or what is incorporated inside that proximal scutum? Ligament between the two proximal sesamoid bones, intersesamoidial ligament. And so what is the form of this proximal scutum? Fibrocartilaginous, allows passage of the DDF and SDF tendon with least amount of friction between the structures and the tendons. Okay. Now as we go further down, what structures are those? What are these two ligaments? This one, okay. This one and this one. What are these two ligaments? Okay, middle or oblique sesamoidal ligaments. Now if I transit all of them and try to pull them up, then I'll be exposing the cruciate and short sesamoidal ligament that I cannot see at this point because those are covered by straight sesamoidal ligament and oblique sesamoidal ligaments. Okay. So how many straight sesamoidal ligaments are there? There's only one from the distal end of the both proximal sesamoid bones and to the proximal end of the middle phalanx. Okay. Between the two insertion divisions of the superficial digital flexor. Okay. Then how many oblique ligaments are there? There are two of them, but they don't go to the middle phalanx. They end at the lower part of the proximal phalanx. And then cruciate, they simply again from the sesamoid bones to the proximal phalanx. And the short also from the sesamoid bones to the proximal phalanx. Okay, after looking at those ligaments there, we also saw the extensor slip. So we saw the long digital extensor in both of these specimens. These are the remnants of the cranial tibial as well as this is the peroneus tertius and cranial tibial muscle. Okay, these are the remnants of that. What structure is this?
Your
Okay. This is the trochlea of the talus. Again, trochlea of the talus has two ridges, lateral as well as medial. Now, which one is lateral? Which one is medial?
lateral,
Okay.
medial.
Now here, the medial one is slightly larger, but usually you're going to see the more free one is this is the lateral side because of the calcanean bone. Okay, and so that is your lateral ridge of the trochlea, and that's the medial ridge of the trochlea. Something important is located, or this part of the lateral ridge may sometime fracture and float into the joint cavity. Okay, so that is the medial ridge. That's that's a lateral. That's medial. What about orientation of the ridges of the trochlea? Obliquely, ventrolateral. While in the other animals, like in the ruminants as well as in the dog, they are straight. They are vertically oriented. What structure is this?
Lateral collateral ligament.
Okay. Okay, now we are just at the
Talus.
hock joint. Specifically, we are looking at the tarsocrural joint, and that is the collateral ligament of the hock. Now, which collateral ligament? Medial. Okay.
Here,
And that's the lateral collateral ligament.
lateral collateral.
The dorsal tarsal ligament is going to be something which is present here, but again, something which is not so important. The dorsal tarsal ligament would usually be responsible for making the lower joints immovable as well. Okay, but again, clinically that structure is not so important. Then what else we see here?
Straight.
This structure and this structure. What are those? One located more medially, one located more laterally on the plantar surface of the calcanean bone. That is your long plantar ligament. Okay, so that is the long plantar ligament, and that is the flexor retinaculum. What would you expect here passing through that opening or that passage?
Vessels.
Yeah, deep digital flexor. But remember, not the superficial digital flexor, because SDF is away from that. It is on the top of the calcaneal bone. Okay, so we have SDF running here, while DDF passing through the flexor canal of the tarsus. Okay, so that's the flexor canal of the tarsus, and the deep digital flexor is secured by the flexor.